years. I've been, my current project is called HICapacity, and it's close to being, close to submitting for test flight. Yeah, spent the past 3 days since my computer died, so I'm playing catch up. 6 to 10 hours a day. So I'm going to go Friday.
Kyle, patience, very sporty.
A great friend.
Yeah.
Skills and computers and things. I'll just probably just watch you guys.
Hi, I'm Holger. I do develop apps of different sorts, including iOS. I've been doing this for a while, longer than I care to remember. So it's great to be here. It's my second time.
Neil, I've just been doing this for about 8 months now, something like that. And I just have fun, look forward to stuff.
Right.
Yeah.
Let's do it.
I have a pilot. I just focus on switch as a hobby.
Hi, my name is Leo. I've been developing for about 2 years or so. Right now I'm trying to get back to the basics, and I've been trying to brush up on like just, coding agnostic, kind of like data structures, complexity analysis. Haven't really been touching too much Xcode lately, but just kind of general programming things.
Yeah.
I'm David. I'm from Manoa. Currently working on a Tide app. The submission of this app is the end of a contest, so it's coming up in 2 weeks. So really looking forward to that.
Is it purple mining up?
Yeah.
Because of my situation and everything, I can't. But I have good friends with Kelsey and a few others.
Oh, nice.
Yeah.
No, I-
I just had to let her know that I couldn't do it because of me planning to leave and and this thing I'm working on, obviously. Taking on like that.
So in terms of that Tide app, right now I'm putting on the finishing touches. It's basically finished, but I really want to make it so that when you kind of change its dial, I'd like a button that I have set up. I'd like to animate the title of that so that instead of it just showing up, I kind of want the numbers to scroll in, almost like a slot machine. So I really don't know how to do it yet, but that's what I'm interested in doing, kind of stuff on that.
You can just look up on GitHub and source.
Yeah, see what there is, right? Yeah, so that's what I'm working on. So that was the introductions. So any questions before we dive in? Any questions about Sprite Kit that maybe you brought into tonight? Or shall we just dive right in?
Dive right in.
Okay. So last time we did a project, and I thought it was pretty helpful to be able to see where we're headed, rather than just code, and like, oh, I don't really know what we're doing here. So downloaded the code. I'm going to just find this link that we put up for this session. And I'm just going to go and just show that link so we can go through. So here is the page for tonight. And we'll be following this Ray Wenderlich tutorial. So who's heard of Ray Wenderlich? Okay, we know Ray Wenderlich. Okay. So I'm just going to scroll down. This is a bunch of code going through. We're just going to create the game. So I've got the code right now. I'm going to just start it up in the simulator so we can see it. Run it, and I'm also going to turn the simulator so it renders correctly. Oh, there it is. Got it right there. And just waiting for it to load. And then we're going to be this guy on the All right. I'm going to turn it over one time. So I'm using command and then the right arrow just to turn the simulator. So now that's going. We're just basically making this game. Does anyone have any questions about this game? It's kind of like a side-scrolling shooter. Yeah, it's pretty straightforward, right?
Yeah.
You kind of understand how it goes. Okay, so I'm going to close in the simulator, and then we're just going to dive right into this tutorial. And again, I'm going to be copying and pasting code, so you guys don't have to wait for me typing it in.
Yeah.
But if you want to, I'm totally open to it. So we'll start at the top of this. So first of all, in this tutorial, Ray Wenderlich is saying that this is actually one of the first tutorials he ever did back so many years ago, and it's been updated. I remember doing this tutorial for Cocos 2D. So
Yeah, I remember it too. I remember this exactly.
So let's just go from the top, and please, feel free to ask questions. We've got 2 hours here. If you do need to leave at 7, please feel free to just leave. So notes from Ray, this is an updated tutorial. He just kind of goes through some differences. So last week we covered Unity with the ARKit plugin, and kind of got to see how it is to program with Unity. It's very visual. It's kind of like an IDE, but it also has that visual component. So it's just saying that, you know, a comparison between SpriteKit and Unity. You guys can read this later on. I'm just going to rip through all this stuff. Unless you have questions. Anyone have questions between the two? All right, so let's get right into it. So, Hello SpriteKit. Let's start by creating a simple Hello World project up and running by using the SpriteKit game template that comes built into Xcode 8. So we start up Xcode and create a file, new project, choose iOS application game, and next. So here we go. Create a new project with Shift-Command-N, and we're going into game, selecting game, iOS, click on next. Any preferences what we call this one? Okay. SpriteKit 001. SpriteKit 001, we're going to do it in Swift, and that's it. So I'm going to click on next, and we have a new project. So there we go, just to see what it looks like, because I always like just running it. You know, it's just like I like running it right when I create it, so I'm going to save and run in the simulator. We're just going to see what comes up in the regular SpriteKit game that we started. While that's loading, I'll just jump over to the code. So kind of, who has done SpriteKit before? Okay, so with that in mind, I'm going to, so this is the game. Simple, you can do like a drag. That's what you get out of the box for SpriteKit. So I'm going to quit the simulator and start. So for this one, let's start with game view controller. We're able to see that this is just a regular view controller. You can see UI view controller. There's just a few things where it's loaded in. We are importing SpriteKit right here. So the way that we load up the scene is we're going to grab a scene file right here, game scene, and we're going to bring it in, fill it to the size of the screen, and then we're showing FPS and node count just at the bottom for debugging. Then we have some options for auto rotate, and just that's it. So this game view controller is actually loading a game scene. And here we have like a label node. Instead of adding views as subviews inside of game or SpriteKit, we add them as children to nodes. So it's kind of like an overview. We've got touches, behaviors, all this kind of stuff, but this is just what we get. And now with that in mind, we've gone through just a game project that you get out of the box. Let's head back into the tutorial. So we've done this. We've written out the name, kind of shown what the default looks like. Now we're going to head over to the initial setup. So we head over to game scene. I'm going to move this to the left a bit so you can see it. So initial setup over here, and then we're going to go in for the what do you guys call this one right here? Project properties or project settings?
Yeah.
Project settings.
Yeah.
So under here we wanted to work on the landscape, and we don't want portrait. So in this initial setup, it wants us to uncheck portrait, so we only deal in landscape left and right. And I think that's it for here. So we're scrolling down. See, he wants to put requires full screen, so I'll put this one as well. And we scroll down some more. Second, delete gamescene.sks and actions.sks. So we go back in, game scene and actions. I'm command clicking, and I'm going to go command delete. And for this one, I'm just remove references. I don't really need to remove it from my entire folder. So save, and then I just want to make sure I have my changes there, so I'm doing Command R to run it one time. While that's going, I'm going to just keep scrolling down here, and Command right to get it into the right orientation. Waiting. Okay, great. We have our nodes here, no nodes, and 54.5 frames per second. Great, we're on our track. On track. Quitting the simulator, head it back in. So we've removed these two things. Next we open GameViewController.swift and replace the contents with the following. So I'm just going to copy all of this. GameViewController, put it over here. Collapse the side here, and I'm just going to paste it in here. Command A, select all. Command V, to paste in. This is kind of scary to me, just personally, so I'm going to save it and run it again. I just want to make sure it works. It looks like it's fine.
It doesn't hurt to check in case of typos or
Yeah.
stuff like this.
Okay. So it looks like we're good. So So I'm going to just quit the simulator again. Any questions about this code right here? Kind of went through the game view controller in the stub project that we get already. So it's just kind of debug, shows, and everything like that. Moving on, unless there are questions. So game view control is a normal UI view control, except that its root view is SK view, which is a view that contains a sprite kit scene. Here you've implemented view did load to create a new instance of the game scene on startup with the same size as the view itself. That's it for initial setup. Now let's get something on the screen. So adding the sprite, first download the resources for this project. The zip file, I download it to my desktop. Go to my desktop and I write here for resources. So we've got sounds and we've got sprites. So what he wants to do here is we want to drag these resources into our image assets. So I'm going to go back to the project. I'm going to hit on assets. I'm going to make sure that I'm in the right scene here because I've got two projects open. And this is the one that was already done. So I'm just going to minimize it. I'm going to just copy it. Back into this project right here. And they want us to drag it into image assets. So there we are. I'm going to just Option Command left arrow to move it over. And I'm going to select all of these images right here. And I'm going to copy them by just dragging them in. So there they are. That looks pretty much like what his screen looks like. So I think we're good to go. And I'm not going to build on this one because I'll get anything will break when I just bring assets. So that's S saving. Moving down. Any questions? How's the speed? Is it fast? Good. Then drag the sounds folder from the resources into your project navigator. Make sure that the copy items into destination groups folder, if needed, and create groups are checked, and that your sprite kit simple game target is selected. Okay, so he's dragged it into its own folder here, sounds. So I'm going to move this one back over to the left, go back here to the sounds folder, and I'm just going to drag this one in, the folder itself. Okay, so this is what he meant, copy items if needed, and we have the target set right here. So I click on finish, and now we have our sounds. Looks pretty much like he has it right here. So it's good to go. I'm going to save and just build and run in the background. Should we go? And I'm going to keep going. Next, open gamescene.swift and replace the contents with the following. So I'm going to copy all this stuff. And I'm going to head back over to gamescene this time. Command A to select everything. Command V to paste it in. Command S, saving again, and I'm going to run it one more time just to make sure it's all good. Looks good. And let's just take a pause here. Does anyone have any questions about this code right here? I'm just going to quickly run through it here. So we're just creating a player SK sprite node with an image that we have here called player. It's just creating it. So now we have a sprite node. And then the did move to view, SK view, you kind of think of it as the view did load before like sprite here. So in here we're setting the background to white, putting this player that we've created in a position, CG point, and then we're adding child. So add child is like add subview in views.
I have a quick question. That the view or did move to, does that correspond to did load or did appear or will appear?
Let's do a quick search.
Because I used the exact same code and I kind of just took it for granted, but looking
I
at
think
it
it's the same, from what I remember, it's the same as view did load.
as view load.
Yeah.
I kind of just took it for granted, but I didn't. Yeah.
You guys got any suggestions of what to search for? Is view did load. Like, did load. Leo, I'm just gonna make a note of this one.
Yeah, I'll go ahead and look it up as well.
Okay.
I get the sprite kit quote from Winterly, and they explain it in there.
Okay.
I want to try to find it.
Okay,
Make sure
right.
about everybody.
So I'm just gonna keep going with the tutorial, and if you guys, if you find it inclusive, just shout it out or something. Okay, so bringing back Firefox, closing this one out, and CFXR. So we're back in here in did move. So we've created our sprite now. So we should be able to see it now because we've added it. So I'm just going to run it one more time. Command S, Command R to run it. And we should see the little player right here on the left. There he is. That looks great.
Yeah, it's cute.
Cool. All right, so I'm going to Command Q. And we'll keep going. So I've mentioned all this stuff. I'm going to just keep going, and we saw our little player guy right there. The ninja has entered the building. Next, moving monsters. Next, you want to add some monsters into your scene for your ninja to combat. To make things more interesting, you want the monsters to be moving, otherwise there wouldn't be much of a challenge. So let's create the monsters slightly off screen to the right and set up an action for them telling them to move to the left. Add the following methods to GameScene.Swift inside the class before the closing curly brace. So I'm going to just grab all of these, and we're going to make these instance methods within GameScene. So now in here, inside of the class, I'm going to put it right after the player, and put it right here. Saving it, running it. So let's just quickly go over this. We've got a write-up. I'm going to leave the code on the right-hand side and walk through what Ray is talking about right here. I'm not seeing anything here, but let's just go through. So, so here's our new code. He says he spelled out things in a verbose manner here to make things as easy to understand as possible. The first part should make sense based on what we've discussed so far. You do some simple calculations to determine where you want to create the object, set the position of the object, and add it to the scene the same way you did for the player sprite. So that's kind of what he did here. He just created a monster sprite. He created this position right here, and then he is positioning the monster. He's added them to the node, and then he is creating an action to move the monster itself. So we have add monster in here, but we are not calling it yet. That's why we're not seeing the monsters move. So I'm just going to move these down. Does anyone have any questions? Feel free to stop me if you have any questions. Okay, one last thing before you go. You need to actually call the method to create monsters. And to make things fun, let's have monsters continuously spawning over time. Simply add the following code to the end of didMove2. So we're just creating an SK action right here that we're going to apply to the monsters. So didMove2, right here, we're adding it. So this SK action will run and repeat forever. This SK action is a sequence where it runs this one, and then repeats and repeats and repeats. So we're calling the add monster, and then we're waiting for a duration. So that should be good, and we should start seeing the monsters move over now to the ninja. So Command S and Command R to make it run. There we go. So it's moving. It's pretty cool. Does anyone have questions about this? It's pretty fast, yeah? Pretty fast to just get stuff moving on the screen. Okay, so Command Q to quit the simulator.
Collision.
There we go. First we'll do shooting projectiles, Jay.
Of course.
At this point, the ninja's just begging for some action. So let's add shooting. There are many ways you can implement shooting, but for this game, you're going to make it so when the user taps the screen, it shoots a projectile from the player in the direction of the tap. I want to use a move-to action to implement this to keep things at a beginner level, but in order to use this, you have to do a little math. This is because the move-to action requires you to give a destination for the projectile, but you can't just use a touch point because the touch point represents just the direction to shoot relative to the player. You actually want to keep the bullet moving through the touch point until the bullet goes off screen. There's a picture that illustrates the matter. So you do a touch and you want to have it move all the way. If you just did a touch, it would just move here and just be done. So, as you can see, you have a small triangle created by the X and Y offset. From the origin point to the touch point, you just need to make a big triangle with the same ratio, and you know you want one of the endpoints to be off the screen. To run these calculations, it really helps if you have some basic vector math routines you can call, like methods to add and subtract vectors. However, Sprite doesn't have any by default, so you have to write your own. Luckily, these are very easy to write. So, he's written them all for us. We're going to just copy these.
Yeah.
And inside of GameScene, right before the GameScene class, right? So operator overloading right before the GameScene class. Here, we're going to pop these in right before the GameScene class. Command V to paste them in. Command S to save, and Command R to run just to make sure it compiles and everything. Looks good, build succeeded. I don't think we're calling any of this yet though. So it should still be the same thing of the ninja and the guy who's walking inside. No touch behaviors yet, but we have the vector creation code in now. So I'm going to quit the simulator one more time. Anyone want to just go over these? Would it be interesting? Or?
Actually, I'm kind of interested in the operator
Overloading. Okay. All right. Is there any specific one you wanted to?
I don't know how it works. So
Jay, did you want to talk fill this question, operator overloading? Because I remember you mentioned it a bunch of times before.
Oh yes, because operator overloading kind of reminds me of operator overloading in C++, with some differences. It's a syntactic sugar of, let's say you, give me an example, like if you want to,
Close the door real quick.
sorry.
Go for it, Jay.
Let's say you create a vector class, and let's say you want to add 2 vectors, and you create a function called add. Every time you want to add a vector, you would say you instantiate one, let's say vector d, right? If you want to set, you would have to do instantiate. You have to call it like the name of add and then the parameter. So what operator overloading does, I think these are, global. Is it global?
To this file.
Yeah, to that particular namespace. So if you operate it, it's like A plus B is like saying A dot add B instead of writing down. So easier way of expressing that same method call.
Mm-hmm.
These are actually method calls, but just easier to look at.
So this could have been done with absolutely no
Without overloading, but it's just
overloading. It just makes it look easier within the actual math.
yes,
Yeah.
yes.
Okay. So just to kind of tail on, I didn't hear everything that Chase said because it closing the door, but on line 3 right here in the code, now we have a function on the with the name plus.
Yep.
Yeah.
Once it gets 2 arguments that are both CG points, it's going to use this because it's the closest scope.
Yeah.
It's smashing the plus where
Yeah.
it would usually be used.
It's another way to say A dot add.
So are these like special characters?
I don't think so.
No.
Just parsing through. Just
Yep.
if it sees a plus and it has these 2 left and
Like,
right.
Yeah.
I mean, but could you do like function A, and then you have a left and right?
Yeah.
Have it
I would
return?
imagine you could.
Oh,
Yeah.
Yeah, you could. That's the standard.
You want to do a playground and mess around with it?
Oh, yeah. I was just wondering if it was contains like plus minus, like certain characters could be overloaded
I
as
don't think
operators.
so. I don't think so.
Oh, you could like make your own thing.
I think so, yeah.
Yes.
Yeah.
All right, so we're moving on to the tutorial unless anyone has any other questions. Okay, keep going. Here's standard implementation of some vector math functions. If you're confused about what's going on here and are new to vector math, check out that quick vector math explanation. Next, add a new method to the file. Again, before the closing curly brace. Okay. Before the closing curly brace is going to be within class right here. So we're doing an override here. I'm just copying all this stuff right here. Copy and pasting right here. Saving and running to make sure it compiles. Looks good. Okay, so there's a lot going on here, so let's review step by step. Is this helpful for you guys? So one of the cool things about SpriteKit is that it includes a category on UI touch with location in and previous location in methods. These let you find the coordinate of a touch within the SK node's coordinate system. In this case, you can use it to find out where the touch is within the scene's coordinate system. That's pretty cool. You then create a projectile and place it where the player is to start. Note, you don't add it to the scene yet because you have to do some sanity checking first. This game does not allow the ninja to shoot backwards.
A big budget to happen.
You can then subtract this projectile's current position from the touch location to get a vector from the current position to the touch location. If the x value is less than 0, this means the player is trying to shoot backwards. This is not allowed in this game. Real ninjas don't look back, so just return. Otherwise, it's okay to add the projectiles to the screen. Convert the offset into a unit vector of length 1 by calling normalized. This will make it easy to make a vector with a fixed length in the same direction because 1 times length equals length. Multiply the unit vector in the direction you want to shoot it by 1000. Why 1000? It will definitely be long enough to go past the edge of the screen. Add the shoot amount to the current position to get where it should end up on the screen. And finally create move to with duration and remove from parent actions like you did earlier for the monster. Build and run, and now your ninja should be able to fire away on the oncoming hordes. So let's go back to the simulator that's already running it, and let's see if this guy shoots some projectiles. Boom! All right.
Now.
In business. But now I think we're going to collision detection next, huh?
Yep.
They're ghosts. Best way they can. Yeah.
Yep.
All right.
Well, technically, you can't really hit ghosts, but besides that point there.
All right. Any questions before we go into collision detections? All right. Here we go. So now you have shurikens flying everywhere, but your ninja really wants. But what your ninja really wants to do is to lay down, smack down. So let's add in some code to detect when your projectiles intersect your target. It's one of the nice things about SpriteKit is it comes with a physics engine built right in. That was amazing. It has been fantastic. Not only are physics engines great for simulating realistic movement, but they are also great for collision detection purposes. Let's set up the game to use SpriteKit's physics engine to determine when monsters and projectiles collide. At a high level, here's what you're going to do. You guys want to hear this out?
Go for it.
Okay. Set up the physics world. A physics world is a simulation space for running physics calculations. One is set up on the scene by default, and you might want to configure a few properties on it, like gravity. So he's kind of saying that the physics world is baked in. There's already one in this scene. Create physics bodies for each sprite. In SpriteKit, you can associate a shape to each sprite for collision detection purposes and set certain properties to it. This is called a physics body. Note that the physics body does not have to be the exact same shape as a sprite. Usually it's simpler, approximate shape rather than pixel perfect, since this is good enough for most games and performant. One good thing about SpriteKit that I've noticed is that if you have an image, instead of you having to actually, figure out how many pixels this way and this way to figure out where the collision bounds of this image will be, SpriteKit has it built in that it will create the physics bounds based on the image that you pass in, which is fantastic. So next, set a category for each type of sprite. One of the properties you can set on a physics body is a category, which is a bit mask indicating the group or groups it belongs to. In this game, you're going to have two categories, one for projectiles and one for monsters. Then later, when two physics bodies collide, you can easily tell what kind of sprite you're dealing with by looking at its category. Finally, set a contact delegate. Remember that the physics world from earlier? Well, you can set a contact delegate on it to be notified when two physics bodies collide. There you'll write some code to examine the categories of the objects, and if they're the monster and projectile, you'll make them go boom. Now that you understand the battle plan, it's time to put it into action. Collision detection and physics implementation. Start by adding this struct to the top of GameScene.Swift. So we're just doing a physics category struct at the top. I'm going to stop that one, head back into our game scene, scroll up to the top. Man, this looks ugly, doesn't it? This right here. But we'll leave it. I'm going to put the physics category right here, paste it in, save, and build. I'm going to run it just to make sure it builds. Good. So I just about done this physics category. This is setting up the constants for the physics categories you'll need in a bit. No pun intended. I don't even get the pun in that one, but moving on.
You bit. No, because you're dealing with a bit mask.
Oh, gotcha. All right, so note, you may be wondering what the fancy syntax is here. Note that the category on SpriteKit is just a single 32-bit integer and acts as a bit mask. This is a fancy way of saying each of the 32 bits in the integer represents a single category, and hence you can have 32 categories max. Here you're setting the first bit to indicate a monster, the next bit over to represent a projectile, and so on. So with that being said. So next, mark game scene as implementing the HICapacity contact delegate. So I'm just going to copy this one and paste it right in here, quick comma. And now it is conforming to the protocol of a HICapacity contact delegate. So I save and build. Great. So we're going to keep scrolling down. Then inside did move to view, add these lines after adding the player to the scene. So did move to view. Here, and we put this after creating the monster sprite. There's the monster sprite, add monster sprite here, put it right up here. Save, so in here we've got our physics world, we're setting the gravity right here, so there's kind of no gravity, it's in the middle. And then the physics world.contact delegate setting it to the game scene right here. Any questions?
I have a quick question. Going back to that physics structure that
Oh.
I don't quite get what they're doing here, or what the purpose of this business categories.
So let's see. So we're creating an unsigned 32-bit integer here, and then these are just what we're doing here is we're just making two different numbers for the unsigned 32-bit integer. So one just has this, and then this one we're adding on, I guess, another bit here, so equals to 2.
So I mean, the way I see it, because it's just be like an enumeration of integers. It seems like. What's the purpose of making it an unsigned 32?
The reason why instead of using an enum or like a regular integer is because of the space. If you because each integer in Swift or most languages now are at least 32 bits or 64-bit integer depending on the platform. So with one integer, you can always add, instead of using this one 32-bit sampler can replace 32 integers, each containing 32. So it's a big space saver, because 32 actual enums take at least 32 bits, right? So like Boolean are also 32-bit, something. But if you have 32 of those, 32 times 32 is it's a big. It takes up quite a bit of space. So, and besides, you're only doing like a set or reset. So, so it makes things a lot easier.
Right. Does it make it a little clearer?
I mean, that's what I thought of first. That it's some sort of it's going to save some sort of memory.
Yeah.
In case you have a lot of like 1,000 things.
Yes, exactly.
Instantiations, but I still don't see how it's saving that much memory. I mean, you're still using an unsigned 32.
Like you're just using one variable to store 32 items. So
I don't understand that part, Jay. That you lost me on that one. You're using one variable to store 32 items.
So we're using one integer,
right,
to store 32
each
categories.
Bit, yeah, exactly.
Potential categories.
Exactly.
Okay.
That's the item. It's that category. Instead of using separate variables for each item.
It makes a lot more sense.
Yeah.
So basically, we have one int, one 32-bit int, and within each of these, I guess, bits of it, you're storing a different.
Yeah, the position. Each position is occupied by an item. So you can't have. Notice how. You notice it's like 1, 1, 0.
Right?
Yeah.
Okay.
You only each item, each category there only allows 1 bit. You're using only 1 bit, like 1, 1, 0. The next one would be 1, 0, 0. You're not going to be doing 1, 1, 0.
I'm almost there. I almost got it.
Yeah, that's a very pretty subtle.
Okay, so I think I'm getting it. So the UI int is 32 bytes.
Bits.
Oh, it's 32 bits.
Which is 4 bytes. 8 bits is a byte.
But each.
We can whiteboard it too.
Yeah, let's whiteboard it.
Each bit can only be 1 or 0, right?
Yeah.
Yeah.
So it's like saying something like a monster is a 0 and a projectile is a. No, that doesn't make sense either.
No, monster. I think it'd be easier to whiteboard this one.
Jake, you want to do it?
Okay. And in fact, one of my apps does something like that. And I'm going to do an ask for this one in the future. Okay. I'm not going to write all 30 because it's just tedious. See if it's, let's say if 1, right?
Yep.
Okay, and just say
It's binary notation, right?
1,
That's what we're looking at too.
3. I'm just
B.
using bits. I'm just look there. Because max. Okay. None is 0, right?
Okay.
It's one category. All is pretty much 1.
One's in all 32, right?
Right. Then monster is 1. And then projectile is bit 2. I think so you can, since there's only 32 possible, because each, this is like category, right? Like each bit represents some kind of category, item, or like a flag or something. So the most you can actually put is 32. So each set bit represents an item.
A category.
Yeah, a category in this case.
The question is,
yeah, you can put up to 32. That's the most that you can put. Unless you decide to use unsigned 64-bit, then you can use to 64.
But still, each the way maybe I don't understand it, but the way I see it is that each instance of an object within the space is going to have its own. It's going to need a uint32, right? It's going
no. In this case.
So you need one uint32 for the whole
category in this case. They're used. I think it's a global variable, is it?
Yep.
So that means this integer will only allow you to store up to 32 items, and each set bit, each position here represents that category.
So I still don't quite get it. Like, let's say we had like 4 monsters and 2 projectiles.
Okay.
How would that be represented in one uint32?
so it's actually the uint32 is going to be assigned to the physics body. So it's kind of just labeling it as the category.
Yes. It's a label.
So it's not like all the categories have to reside, well, I guess all the categories have to reside in this, all the possibilities, but we won't have all those possibilities assigned to, I'm sure you know this already, but we won't have that assigned to every single physics body that we need to keep track of. It's kind of like a label for each one, a unique label.
Right. Exactly. So if you put monster 2, then you go B0, B1, 0, 0.
So let's say I create a new physics body. Then they would have like an instance variable of category, of physics category. And that would be an instance variable of type uint32.
Is it possible for you to write it on the...
Yeah.
Okay.
So let's say I have like a class of monster, right? And then inside could be like physics category. This is a uint32. So I mean, that's what I was saying, like each
one has its own.
Each instance has its own
You could do it that way.
uint32, right? So I don't see how this is same space. That was my question.
Oh, I guess I see it as a bit mask, if that makes sense. It's like, it's kind of a way of you, like, with 32 bits worth to kind of, I'm getting lost in this.
Go for it. Go for it.
Right?
Yeah, go for it.
It's almost like a pattern that you apply that when you iterate through these nodes that you're working with in the physics categories, when it finds that pattern, then it says, okay, this is obviously a monster because it has that pattern.
Right.
But I guess
couldn't I just go physics category in or something, or create a enum category, and then just do case monster case.
Yes, you can do that.
Projectile.
Yes, you can do that.
Right, but I mean, in my mind, this is the same thing, right?
Yeah.
This could be a uint32, or this could be a category.
Yes,
I
you
think
can do that.
the reason we're keeping the uint32 is because within SpriteKit,
Yeah.
the physics category is expecting it, like the category bitmask is expecting a uint32.
Oh,
Exactly.
it's something
that's
to
what
do
we
with
set up.
it's something to do with how Sprite is set up.
I believe so, yeah.
Exactly. And in fact, a lot of games tend to use bitmask to conserve space.
Right.
Because like I said, if you did that Eno and they're like 32 bits, and you have 32 plus 32
Oh,
times
you know what I
32
just
bytes.
realized actually though, that if you were to use an Eno, you'd have to choose monster or projectile. Whereas if you use a bitmask, it could be a monster and a projectile.
Exactly.
Oh, okay, I see that. But you can have multiple categories
In one
within
setting.
one UI. Oh,
Exactly.
I think I can.
Yeah.
I'll take it.
Exactly.
That's helpful. I think that's helpful.
It's actually, these bitmaps are very good if you want to have multiple flags in one. And you're in space. I like
Right.
that.
Yeah, I've never seen that like that before. But it's pretty tricky, but it's smart. Yeah.
Any other questions? Or?
If you do a lot of low-level programming, that's what you do
See
a
that,
lot.
yeah.
In fact, one of my apps where I do grids, I kind of play around with the bits and the positions. It's tricky. It's easy to mess up because
Right.
the key is there's a reason why you do unsigned in, because if you don't, you're gonna overflow in a way to
Right,
get
right.
negative. So you
Right.
gotta, you really, for these kinds of things, you really want to unsigned in.
Right.
Just the nature of this.
Well, I'm going to dive back into the code. We'll keep going. So we've got about 13 minutes left. So just kind of a heads up if anyone needs to leave at 7. We're going to keep going. We've got a lot more to go though, so but we'll just go for it. So this sets up the physics world to have no gravity and sets a scene as the delegate to be notified when two physics bodies collide. Inside the add monster method, add these lines right after creating the monster sprite. Copying these ones. Right after creating the monster sprite. So add, I'm going to search, F, add monster. There it is. I'm going to command click to jump to the definition down here. And it says right at the bottom, I believe this is where it is. After creating the monster sprite. Okay, so I've created the monster sprite with the position here. I'm going to put it in right here. Pasting it in. So right now with these lines 86 to 90, we're all just dealing with physics bodies now. So within the SK sprite node, we have an SK physics body, which is right here. And we're just creating it with a rectangle of the monster size. It's dynamic, so it can move around. The category bitmask is set with the physics category of the monster. The contact test bitmask is set with the projectile. And the collision bitmask is set with the physics category. So I don't have any questions about that stuff. Go ahead. All right, so I'm just going to skip all this. Maybe I'll read it because this contact bitmasks get kind of, bitmask, collision bitmasks get kind of foreign. So just quickly go over this. So number 1, right here on 86, creates a physics body for the sprite. In this case, the body is defined as a rectangle of the same size as the sprite because that's a decent approximation for the monster. Number 2 sets the sprite to be dynamic. This means that the physics engine will not control the movement of the monster. It will go through the code we've already written using move actions. Sets the category bitmask to be the monster category defined earlier. Line 4, the contact test bitmask indicates what categories of objects this object should notify the contact listener when they intersect. We choose projectiles here. And finally, the collision bitmask indicates what categories of objects this object, the physics engine, handles contact responses to. If you don't want the monster and projectile to bounce off of each other, it's okay for them to go right through each other in this case, so you set it to 0. Next, add some similar code to touches ended right after the line setting the projectile's position. So I'm looking for touches ended, and I'm going to be creating these physics bodies for the projectile. I'm going to search for touches ended here, and the projectile is right here. I'm looking for position. Just paste them in right here. As a test, you can see if you understand each line here and what it does. If not, just refer back to the points explained above. As the second test, see if you can spot 2 differences. I'm going to skip that. In the interest of time. Save and build just to make sure it builds. Good to go. Keep going. Next, add a method that will be called when the projectile collides with the monster before the closing curly brace. Note that nothing calls this automatically. You'll be calling it later. So copying this function and collides with the monster. Where would that be? You guys know this. Just chat that. Last one this was. Next, add a method that we call when the projectile collides with the monster. Okay, so it's just up there.
So this is a instance method right there. Save it, build it. Good to go. All you do here is remove the projectile and monster from the scene when they collide. Pretty simple, huh? Now it's time to implement the contact delegate method. Add the following new method to the file, again before the closing curly brace. So copying this. Since you set the scene as the contact delegate for the physics world earlier, this method would be called whenever two physics bodies collide and their contact test-fit masks are set appropriately. There are two parts to this method. This method passes you the two bodies that collide, but does not guarantee that they are passed in any particular order. So this bit of code just arranges them so they are sorted by the category fit masks, so you can make some assumptions later. Finally, it checks to see if the two bodies that collide are the projectile and the monster. If so, calls the method you wrote earlier. Give it a build and run, and now when your projectile intersects targets, it should disappear. Saving and running. Alright, so we should be able to shoot and destroy some monsters. We're close to the end, finishing touches. Boom, alright, it's working. Alright, I'm getting lost in this. Quit. Alright, finishing touches. You're pretty close to having a workable but extremely simple game now. You just need to add some sound effects and music. Since what kind of game doesn't have sound and some simple game logic? You already have some cool background music. I made an awesome pew pew sound effect in your project. From the resources for this tutorial you added to your project earlier, you just need to play them. To do this, add these lines at the end of did move to. So copying these, copying these, and moving back to game scene, stopping the project, searching for did move, and putting this at the end. So we've got the background music, so this is start up. And on the simulator, I don't think it's going to play, so you're just going to have to take my word for it that it's playing in the background. Moving down, this uses SK Audio Node, a new class introduced in iOS 9, to play and move the background music for your game. As for the sound effect, add this line to the top of touches ended with event. So copying this, I'm going to search for touches ended, and just putting it at the top. So this action will play the sound in qq-lay.cam. Saving that, building it, should be good to go. Pretty handy. You can play a sound effect with one line. Build and run, enjoy your groovy tunes. If you don't hear the background music, try running on a device instead of a simulator. Game over, man. So I think we're finally at the end. Now let's create a new scene that will serve as your you win or you lose indicator. Create a new file with the iOS source Swift file template. Name the file game over scene and click create. So I'm going to copy this by double clicking on it, Command C. And we're just creating a new Swift file. So I'm going over to the file editor, control, click, new file, Swift file, pasting in the name, create. Good to go. And copying all this code. And then they're going to tell us what we did here. So Command A to copy it all, Command D to paste it in, Command S to save it, Command B to build it. And while that's building, so we'll just go over this code over here. So number one sets, scroll up a bit. Number one sets the background color to white. Number two, based on the won parameter, sets the message to either you won or you lost. I like this tertiary, what is this called?
Tertiary.
Tertiary operator.
Yeah.
Ternary operator.
Turning on.
If else.
But
Nice
the thing is,
one-liner. Love it.
yeah, try not to embed too.
Right, yeah.
It's confusing.
All right, number three. This is how you display a label of text in Scene Sprite Kit. I always use labels in Sprite Kit. They're awesome. It's pretty straightforward. You just create it, set the font, set the text size,
Cool, I like
composition,
chalk duster.
add it. It's great.
I
You like chalk duster?
Yeah. In my app, I added a few chalk duster fonts.
Nice.
I'll show you later.
So it's step 4 now. Finally, it sets up and runs a scene, a sequence of 2 actions. I've included them all in line here to show you how handy this is instead of having to make separate variables for each action. First, it waits for 3 seconds, then it uses the run block action to run some arbitrary code. Number 5, this is how you transition to a new scene in Sprite Kit. It's kind of like a view controller, change it to a new view. So First, you can pick from a variety of different animated transitions. This is so much like Coco's 2D for how you want the scenes to display. You choose a flip transition here that takes 0.5 seconds. Then you create the scene you want to display and use the present scene transition method on the self.view property. Finally, step 6. If you override an initializer on a scene, you must implement the required init coder in an initializer as well. However, this initializer will never be called, so you just add a dummy implementation with a fatal error for now. I'd like to pause here in number 6. I always have this coder thing. I don't really understand it. Does anyone have like a read on it? Why would you put in this NS coder stuff?
It has to do with the storyboard, right?
Has to do with the storyboard.
If you're trying to initialize it from the storyboard, isn't it something like?
Or
It's either with the storyboard or if you're trying to like save your object as an NS object.
Exactly.
Okay.
If you're doing serialization,
Right.
or you need to get objects, like if you want to save, all that data
Right.
to a file, a disk, you have to serialize it.
Serialized.
Yeah, that's one way of doing it.
So in this case, they're using this in here because you're overriding an initializer in a scene. I still don't get it. Why would you need to serialize this though?
Like
I don't think you are, but
Not in this
is
case.
just required.
Okay.
Yeah.
Yeah.
required, but there are cases where you may want to do it, like say if you want to store stuff in the background,
Right.
you're gonna have to serialize your data,
Right.
pass back. That's where that function is used. But in this case, you're not doing anything that complicated, so you don't need to. So you have to put something like that to indicate.
All right, I'm going to move on unless anyone has questions. Very close to the end. So far, so good. Now you just need to set up your main scene to load the game over scene when appropriate. Switch back to game scene. Switching back to game scene. And inside add monster, replace the last line that runs the actions on the monster with the following. So the last line, which adds the monster. Monster run, okay, right here. So I'm thinking use action. There we go. Save it. This creates a new lose action that displays the game over scene when a monster goes off screen. See if you understand each line here, if not refer to the explanation in the previous quote block. So let's just look it over real quick. So it's an action, it runs, it's an SK transition, flip horizontal with duration. And it pulls up the game over scene, gives it size, gives it the variable 1 is false, and then self.view present scene. It's a segue, right? Present scene, or that's actually that's a sprite. Yeah, specific one. It changes views. Okay. Any questions? Keep going. Okay. I'm going to skip the pop quiz. Going. Now you should handle the win case too. Don't be cruel to your players. Add a new property to the top of game scene right after the declaration to player. So monsters destroyed. Cool. We can check how many monsters we've destroyed. Command up arrow, adding it to the top within game scene. So we have that added variable, so we can update it. And then inside, add this to the bottom of projectile did collide with monster.
If you're scoring.
Okay. So I'm putting this at the bottom. Monsters destroyed gets incremented by 1 every time this gets called, saving, building it. And then finally here, if the monsters destroyed count is greater than 30, then we do the scene present the scene for game over with 1 equals to true rather than 1 equals to false. And we are at the end. Go ahead and give it a build and run. Then you should now have win and lose conditions to see a game over scene when appropriate. Save, control, or command R. Here we go.
It's really fast hands.
Yeah.
Oh man, game over, so you lose. So you want, I don't know if I can, does anyone want to play? Try to beat it at 30?
There's a lot.
Yeah.
Can we change it to like 5?
Let's do that just to get the thing.
You know, that'll work.
All right, change to 5 right here. Okay, here we go. So just 5 this time. Here we go.
You lost.
Yeah, we're
Try
fine.
it one more time.
That guy's fast. Yeah.
So this
No
quick
worries,
is
man.
going
Just go for it.
Go for it.
Go for it.
Come on, that was 3, 4. This should be it. Oh, shoot. There we go. Winner.
There you go.
All right, cutting that out. So we're at 7:01. If anyone has to leave, thanks for being here. Appreciate it. We're gonna hang out here for another hour. We're gonna hang out. So that's it. I'm gonna stop the stream and then we can take a break.
See you guys.
All right, thanks, Tyler. See you.
Take care.